Hello everyone, welcome to Computer Science 330 Robotics. Okay, learning that online. Lecture number 2. Today will be a very short lecture. Basically introduction to the field of robotics, what is a robot, how does it operate, that kind of stuff. Okay, so let's get to the slides. August 20th, lecture number 2, introduction. And the first question I usually ask my students is, what are the most famous types of robots they know? Okay, let me do this. Okay, so what are the most famous robots you know? And I'll probably ask you some references, some examples from social media, movies, cartoons. And one of the most famous robots out there is R2D2, the robot from Star Wars. Okay, right. So that is a robot, or something we would consider a robot. Then what other examples would you know? Wall-E, right? That would be a robot from the cartoon, very famous cartoon. And their girl. So it's interesting because I don't really know who that is, but whenever I show that to my students, they'll laugh. So that's probably cultural difference, a cultural reference, and I'm kind of out of context. But that lady would also be a robot from a cartoon, of course, right? This course is all about robotics, right? So therefore, for the very first question we need to kind of talk about is, what is a robot? What do we consider a robot, and what is not a robot? Okay, so for example, if I have a toaster or microwave, is that a robot? What do you think? Would that be a robot? Because technically, I mean, it's some kind of technology, right? It's doing something, like you push the button and it's doing something by itself, and then it produces some kind of result. So why would that be? Why would that be not a robot? Then the drone, DJI Mavic Pro, for example, Zoom. So in this case, would that be a robot, right? So a drone, you control a drone, it flies around, takes pictures, takes videos. Would that be a drone? Laptop, right? If you have like MacBook, Macintosh, would that be a robot, right? So again, it's technology, it's doing something futuristic, something very important, something very difficult, something you would not be able to do on your own. And yeah, would that be a robot? Or for example, Hyundai, any kind of car, Tesla, would Tesla be a robot? If the car is self-driving, would that be a robot, for example? Can for example, a regular car not be a robot and a self-driving car be a robot? So like when you introduce that property of being self-driven, can that be distinguishing thing between being a robot and not being a robot? Very good question. So unfortunately, in general terms, in literature, you can't really strictly define a robot. It's basically the same thing as trying to define Mount Fuji, the highest mountain in Japan. If a steep hill suddenly protrudes from the flatland, right? So like you have a flat land and then you suddenly have a hill. So that point, that mark, is basically the border between being a hill and not being a hill, right? So in that case, you can draw a line to show where the mountain starts, but Mountain Fuji becomes higher so gradually that you can't really draw a line. So if you have, imagine that this is like 1 mile, like 1 mile of distance, and then slowly becomes, goes up, the line slowly goes up. You can't really see that, see that border. Pretty much the same thing happens with robots. You can't really see that line, that border between being a robot and not being a robot. When it comes to general literature, general overview, yeah, so it's very difficult to draw a line. Robots are like Mountain Fuji. It's hard to separate something which is a robot from something which is not. Asimo is never so near to speak. Anyone can easily call it a robot, but what about dishwasher, right? It can automatically wash dishes, so you might technically kind of call it a robot. So the line is very blurry. Okay, so our definition, which we're going to use for this class, right? So the robot is an autonomous system that exists in the physical world, so not somewhere in the computer game, not somewhere in the virtual world, not on your phone, but that exists right here, something you can touch, something tangible, right? It can also sense the environment, so it has some kind of sensors. For example, it can sense the temperature, if something is dry or wet, the distance, the wall. It can sense the wall. So it can definitely sense the environment, and it can act on it to achieve certain goal. Okay, so again, physical world senses the environment and acts on that environment to achieve some kind of certain purpose, certain goal. Okay, so this gives us defining characters to look for, right? Autonomous, right? What does that mean? A robot must make its own decisions. So not necessarily it has to be complete, the whole artificial intelligence has to be completely universal. It not necessarily should or has to exist in the world completely by itself, right? But somehow it needs to make its own decisions every now and then when it's needed. Sensor driven, a robot needs to collect information from the environment. Physical world, right? So the real world is complicated and unpredictable. Physical world, goal achievement, a robot should have a purpose. It should do something useful. Okay. So question, teleoperated systems. Okay. So let's say there is a surgery, very important surgery on a person, right? And let's say there are like robotic arms which move things around, and the person who is like surgeon is located, I don't know, 100 feet away in a separate room, and he's kind of moving something in his lab, and then those arms actually are moving inside that room, right? Tele meaning far away, right? So a teleoperated system is a system that is being operated from far away. So a teleoperated system, can we call it a robot based on our definition? Okay, so this system, right, which is performing a surgery but which is controlled by a person far away, is that autonomous, sensor driven, physical, and goal achieving at the same time? What do you think? The answer is no. It's not autonomous, right? So it is sensor driven, it is physical, it is a goal achievement, but it's not autonomous. Why? Because there is a person who's controlling every single move there. So it's not really, it can't really make its own decisions completely. Robotics depend on the interactions of computation, action, and sensing, right? So first off, kind of like you sense something from the world. Let's say again, like you're running into a wall, you sense that wall, and then you compute your action. So according to some algorithm, when you see a wall, what should you do? Should you go left? Should you go right? Should you turn around? Should you turn like 45 degrees in some direction and then kind of redo that, like sense the wall again, try to sense that. So you need to sense something, compute the next action, and then perform that action. Move, turn, left, go, drive, something like that. This class covers both theory and practice of designing algorithms for robots. Hands-on practice is important because robots must operate in the real world. So kind of the difference between this class and, let's say, Computer Science 190 is that in 190 we just code, we don't see anything like physical in the world. Here it's more, you can see actually the result of your code, the result of your work. It's more tangible, it's more visible. You code something, you deploy that to the robot moves around, right? And kind of if it doesn't move the right way, then you need to correct your code. Yeah, so that's why this class is hands-on. Understanding the underlying theory is important because there are many problems that are difficult even in idealized situations. Usually what happens is that, like when we're talking about robotics, a lot of times people would create a simulator for a robot. They would first write the code for the robot and then deploy that to the simulator. That actually happens with drones a lot. And and then you perform simulation on that robot in the simulator, and then you actually go to the real world hoping that the simulator shows exactly the same results as the real world will, right? Because if you crash the drone, let's say, in the real world, it's going to be an issue, you're going to lose a lot of money, but if you crash it in the simulator, you're not losing anything. A good roboticist, a person who's doing robotics, will know about both theory and practice. Robotics is a large field that encompasses the following disciplines: mechanical engineering, electrical engineering. For example, like when you do drones, there is a special types of drones which is called FPV, first point view. And what's interesting is that you can basically assemble the drone by itself. You can buy all the parts, you can solder them all together, and supposedly that should work. And that's why you need to know mechanical engineering. You need to select the proper motors, rotors. You need, like they need to be, I don't know, that big or that big or that big. Electrical engineering, because you need to solder everything together. You need to understand which each chip is doing, how it performs. Computing, right? Well, I guess psychology, but computing because you need to program everything. Our focus is on computational issues, of course, but that does not mean that we can ignore sensing and acting. Okay, so here's an example. Here's the picture of the robot we'll be using. It's called iRobot Create 2. Okay, so can I zoom in here? No? Okay. So at the very center, there is a power button. It's also called clean. Basically, what's interesting is that this robot is designed for cleaning. You probably heard of those robots. You basically like hit the power button, the clean button. It has a brush, and basically it's like a vacuum cleaner. It walks around the room like using a certain pattern, avoids all the walls, and just cleans everything. So it's very useful for people who want to kind of clean their apartments and houses. They can just buy a bunch of those for each room, or even for the entire apartment house. You just push one button and just leave the, I don't know, apartment for half an hour, and then you come back, everything is clean. Theoretically, that's how it should work. Okay. Now, also you have a couple of buttons here. What is it? Day, hour, minute, schedule, right? Clock. Of course, spot, dock. Of course, for us, these buttons will have different meaning because we'll be actually programming this robot to work like in our direction, to follow our purpose. We will not be cleaning anything, right? We'll actually kind of completely wipe out that software. Well, it's already not there, and we're gonna write our own code. Basically, we'll program the movements of the robot, and then we'll deploy the code to the robot, and the robot will be moving in our direction. So here are the dimensions. This robot is very popular, by the way. And one of the, I guess for the first homework assignment, what I want you to do, I want you to find at least two projects. So again, this robot is very popular in the community of people who like robotics. And it's used in high schools, universities, all different schools. And people created super crazy amount of robotics, like amount of projects using this robot. So the internet is flooded with projects based on that robot, that particular model, iRobot Create 2. What I want you to do, I want you to find those projects. I want you to pick the two which are the most compelling, which are the most interesting to you, which are the most fun to look at, in your opinion, right? So there is no right or wrong, just whatever you like. And describe in your own words how the creators achieved that functionality. Okay, and I want you to submit a report, at least 1 page, 1 or 2 pages, submit that to the Blackboard. Homework number 1 will be due on Monday. So for example, I don't know, one of the ways of doing this is, okay, iRobot Create 2, right? So let's go to Google or YouTube, iRobot Create 2 project. Okay. So that's an unboxing. That's not what we need, right? Hack it, build it, create it. It's done by the iRobot, so it's probably official video. It's not that interesting. Yeah, so something like this with the GoPro with very low quality. That's probably somebody creating something using that iRobot and just kind of filming that with using his phone. So for example, that looks fun. Path Walker. So basically, the guy created an like kind of labyrinth, and he's going to make the robot walk around. Okay, so he added like Arduino, I think, to that, right? Yeah, Arduino. That's what we're gonna do. We're going to connect our computer via USB to the robot using this cable, okay? And from the computer, we'll be sending the commands to the robot to move, to stop, to turn around. Okay, so he's walking around. Hold on. Yeah, so hold on. Yeah, so he's going forward, then he senses the wall. He found the wall. Okay, perfect. Now it's going to come back up a little bit. It's going to turn, I guess. Okay, left, right? So it's probably pre-programmed to turn left. And then, yeah, 90 degrees to the left, go forward. Okay, also a wall, back up. Then I guess turn left again, or turn right. Okay, now probably turn right 180, right? Because before it turned 90, now turn right 180. Okay, and now go forward. Okay, perfect. Yeah, so that makes sense. Yeah, so now we can kind of see what it does and how it was achieved. You can basically go through like that kind of labyrinth, right? How does it do that? It goes forward until it bumps into something, turns left 90 degrees, goes forward, bumps into something. If it happens that like it bumped, then it turned left, it bumped again, then you need to turn 180, turn around, and then just go that way. Most likely it'll be open. So now it's turning around to go down towards us, right? And then we'll probably do the same thing. Okay, now it's going to turn left, which means it'll go right that way. Okay, yeah, super slow, of course. Yeah, but that makes sense. Okay, so I want you to take a look at the any of those projects, not this one because I already explained how that works. Take a look at that not only on YouTube but just Google iRobot Create 2 projects and submit a page explaining how they created that, how that program works. Okay, so kind of how they were able to achieve the functionality. Yeah, cool. Hope it makes sense. Hope you guys had fun for this short lecture. I'll see you guys on Tuesday. Again, I want you to submit the notes before midnight today. Homework due on Monday, quiz next Thursday. I'll see you guys later. Bye bye.